to your first Geometry Concepts Flipped video. This is lesson 1-1 in Geometry Concepts, and we're going to be finding and describing patterns. So your goal for today is to find patterns and use them to make predictions. So if we take a look at this first example, we wanted to be able to describe a visual pattern in geometry. So if we look at the pattern below, well, we have room. We've got triangles, we have a square, we have a pentagon, we have a hexagon. Well, the name of it isn't really what the pattern is, but what we're noticing is the total number of sides increases. We went from 3, 4, 5 to 6. So let's write the numbers of each side and each. So like I said, we went from 3 to 4 to 5 to 6. So the pattern that we see, and this is where we're looking at what our statements need to be. We're asking for a written explanation. So we're going to answer the question with the number of sides increases by 1. And so when we're asking you to describe a pattern, you're using your words. Your answer should be a statement, not just increases by 1, but we're going to specifically say the number of sides increases by 1. So the follow-up, this is what we'll take a look at and discuss in class, but on your own, what I want you guys to be doing is pausing the video now and then make your own visual pattern and describe it. So we've got a lot of options out there. This is where you get to show me your creative side. But I suggest pausing it or getting through the video and going back. But the follow-up needs to be done. We will check in class. All right. The other example that we're going to look at is describing a number pattern. Geometry is this wonderful measure of our visual learning and math, and so we're also going to have number patterns. So we want to describe the pattern in numbers. The pattern is 3, 6, 9, 12, 15, 18, and then they're showing that the pattern's going to continue. So if we look at the solution here, it says, notice that the numbers increase. So that's really important. We need to know, is it an increasing pattern or decreasing? We're going to find the difference between each pair of numbers and the previous numbers. We're going to start with the second number, 6, and subtract the first number. And so 6 minus 3 is 3. We're going to take the third number and subtract the second number, and 9 minus 6 is 3. For my third pair, I'm taking 12 minus 9, and that equals 3. If we look at the fourth pair, 15 minus 12 is 3. And then the last pair, the fifth pair, is 18 minus 15 is 3. So if we look at our answer here, it's not the number of sides, but the answer to that one is each number is 3 more than the previous. And so that's what we're looking for when we're talking about these number patterns. You're telling me what each number is doing. All right. If we take a look at the second part, letter B, we've got 1, 4, 9, 16, 25, and 36. Now notice here when we look at the solution, they're not just telling us that the numbers are increasing, but we also need to notice something else about those numbers. Those numbers are what we call our perfect squares. And so hopefully from Algebra 1 last year, remember talking about our perfect squares when we were simplifying radicals. For each number in the pattern, write the number that is squared. So for the number 1, that's 1 squared. 4 is 2 squared. 9 is 3 squared. 16 is 4 squared. 25 is 5 squared. And 36 is 6 squared. So the numbers in our patterns are the squares of the counting numbers, 1, 2, 3, 4, 5, 6. Counting numbers are also what we call our natural numbers. We learn how to count starting at 1. So we're describing it as the square of the counting number. So our 8th number would be 64 because that's 8 squared. So if we look at the follow-up, if the numbers in a pattern increase, must they increase by a constant amount explained? And so you've got two examples here with A and B that are going to help you do that. So once again, I expect you to do that, and this will be a check in class problem. And then make up your own pattern, and I expect this to be a number pattern, and describe it. And so this will be a check in class problem also. All right, let's take a look at the checkpoint. If you notice, I've copied these out of here, and we want you guys to be describing the patterns. And so the checkpoints, we're looking for written explanations. So I'm going to do the first one for you. If we take a look at number 1, we went from having 2 pieces to 3 pieces to 4 pieces or parts. So the pattern here is the whole is divided into one more part each time. So I wanted to model this for you so that you can see what we're looking for. I'm talking about complete sentences, complete ideas. Could we have worded this a little bit different? Yeah, the number of fractional pieces is 1 more each time. We're all going to have some different wording in there, but I want you to focus on describing the pattern using good words and using complete sentences. But the remaining ones for your checkpoints, as always, these are going to be our checking class problems that we share out and bring to the board. So these need to be done, 2, 3, and 4 need to be done for tomorrow in class. All right. Not only were we looking at patterns, but we were also using those patterns to make predictions. So we want you to sketch the next figure you expect in the pattern. So we're going to look at the pattern, and the nice thing about this is our solution tells you where to start looking. The first thing you should notice is that the shading does change. It goes from being a gray to a black and back to gray. So the arrow on the next figure, if we keep altering back and forth, the next color should be black. Also notice that the direction of the arrow changes. The arrow makes a 90-degree turn, and I'm going to put counterclockwise because we're going counter the clock. It's making a 90-degree counterclockwise turn each time. And the next arrow, the figure should point. And for this one, guys, I would say we could use words. Should point to the right. Or if you wanted to use a visual of that, and draw me an arrow in the direction it's pointing, one of those two. So now what you're doing is drawing that pattern. So I'm going to pick up my black pen so it's in black. I'm going to draw that arrow. And then color that in. I'm not a very good artist, and so you guys will learn that about me in geometry. So this is what our solution should look like for the next pattern in the figure. All right, we're also going to make numerical predictions. So we have the pattern 5, 7, 9, 11. We need to make the next 2 numbers. So notice the numbers increase by 2 each time. So when you add 2 to 11, we get 13. Now this 13 needs to become the next number in our pattern, so we're going to add 2 to 13. We get 15. So the answer, the next 2 numbers in the pattern are 13 and 15. If we take a look at the next pattern, we've got -1, then 3, then -9 and 27. So notice first the numbers switch from being from negative to positive. This will only occur in a pattern when you multiply by a negative number. So we know when it changes back and forth from positive to negative or negative to positive that there has to be multiplication by a negative. Each number in the pattern is 3 times the previous number. Okay, 9 is 3 times 3. 27 is 3 times 9. So if I multiply 27 by -3, I'm going to get a -81. Now when I multiply -81 by a -3, a negative times a negative is a positive, and now I get 243. So get that calculator out, pull it up on your computer, pull it up on your phone, and do those. So the answer here is -81 and 243. if we take a look, we're at the last part of the problem. So for these visual patterns, you've got to sketch the next two figures in each of them. And then the visual ones, we need you to write the next two numbers. Be prepared in class to check these. These are going to be our checking class problems. Okay? And also be prepared if I call on you to be able to verbally explain. All right, ladies and gentlemen, it looks like we are just about done with our first video in class. Make sure you're taking the time to rewatch this, pause this, rewind to anything you may have missed, but I will see you in class tomorrow.